Hey math kids, today we're going to talk about permutations. And permutations, we have to remember that order matters. So in this first example it says, list the permutations of the symbols X, Y, Z when they are taken one at a time. Okay? So if we just pick any one of them, we can just do X, and then the next one's going to be a Y, then the next one's going to be a Z. So there's only 3 permutations. Now, if we take them 2 at a time, we could do XY, XZ. We could do YX, YZ, and we could do ZY, ZX. And that's a total of 6 permutations. Okay. Now the last one, XYZ, and we want to do them 3 at a time. So XYZ, XZY, and then YXZ, YZX, and then ZXY, ZYX. So that one's also 6 permutations. Okay. Alright, moving on. We're given a formula to use for permutations. Here, your book doesn't write it this way, but this is how we talked about it in Math 2, if you took Math 2 from me. Okay, so they don't include that NPR thing. But, okay, we have a chess association runs a tournament with 16 teams. In how many different ways could the top 8 positions be filled on the competition ladder? Okay. Cool. Okay, so what we're going to do, this is just going to set up a 16P8. And if we just plug it in, we're going to get 16 factorial over 16 minus 8 factorial. And so that's going to be 16 factorial over 8 factorial. And so if we go to simplify that, it's going to be 16, 15, 14, 13, 12, 11, 10, 9, 8 factorial. On the bottom it's 8 factorial. Those cancel. And so we just need to plug this into a calculator, and when we do that, we get this many permutations. Okay. The alphabet blocks A, B, C, D, and E are placed in a row in front of you. How many different permutations are there? So there are 5 letter blocks taken 5 at a time, and the total number of permutations are just going to be, so essentially this is a 5P5. So that's going to be 5 factorial over 5 minus 5 factorial. Now an important thing to point out right here is that 0 factorial is defined as 1. So we're going to get 5 factorial over 0 factorial, which is 5 factorial over 1, or just 5 factorial. So we just say 5, 4, 3, 2, 1, and that's going to be 20 times 6 times 1, and so that's going to be 120 different ways. Okay, now we want to know how many permutations end in C. So if we put the blocks like this, we're going to fix that position, but there's 4, 3, 2, 1 different ways that we could do it. And so essentially, we're just taking C out of the equation, and now we just have 4 blocks. So it's going to be the same situation, but it's a 4p4, which would just be 4 factorial, or 4, 3, 2, 1. And so that's going to be 12 times 2, or 24. Okay, how many permutations have the form A, B, where these could be other things? Well, there's 3 that could be here, there's 2 that could be here, 1 that could be here. So once again, we're essentially just taking A and B out of the equation, but we have C in there again. So it's just really C, D, E. We're going to have a 3p3, or a 3 factorial, which is going to be 3 times 2 times 1, which is 6. Okay, how many permutations begin and end with a vowel? Okay, so if we look at this, if we look at block positions, so this needs to be a vowel. This needs to be a vowel as well. And so there's 2 vowels that could fill that position, but then eventually only 1 vowel. And then the other, because we have A and E are vowels, and then we have B, C, D that are not vowels. So there's 3 non-vowels, 2 non-vowels, and then 1 that can fill those positions. And so what we're going to have, we're basically going to have a 2 factorial and a 3 factorial. So that's 2 times 1 times 3 times 2 times 1. This is 6, this is 2, and so the total is going to be 12. Okay, we have one more. There are 6 different books arranged in a row on a shelf. In how many ways can 2 of the books, A and B, be together? Okay. So what we can make like a table if we wanted to. So A and B could be first, A, B, and there were a total of 6. 1, 2, 3, 4, 5, 6. Okay, and we can move them to this spot, and we can move them to this spot. Oh wait, we can also flip them though, huh? We could say BA. We could also say AB, BA, AB, BA, AB, BA, AB, BA. Obviously there's X's in all these spots. So we see this is like a very visual way. And we just count it up, and we see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 of those, and since in these four things, like this would represent a 4 factorial because those books could be in 4 different ways. This would be another 4 factorial. This is another 4 factorial, etc. So we have 10 4 factorials, and so we could do 10 times 4 times 3 times 2 times 1, and that's going to give us 24 times 10, so there's 240 different ways. Okay, and that's it, I think. Nope, we got it. No, we have one more. Okay, consider the word calculus. How many permutations can be formed using all the letters? Well, there's 2 C's, 1 A, 2 L's, 2 U's, and 1 S. Okay. So, what's going to happen is if we use all the letters, we have a total of 1, 2, 3, 4, 5, 6, 7, 8 letters. So we're going to get 8 factorial on top. And on the bottom, we're going to get the distinct possibilities of each letter multiplied together. So we're going to get 2 factorial, 1 factorial, 2 factorial, 2 factorial, 1 factorial. So we get 8, 7, 6, 5, 4, 3, 2, 1. We get 2 times 1 times 1 times 2 times 1 times 2 times 1 times 1. Alright, so 2 times 2 is 4, times 2 is 8, so the bottom is just 8, and so we would just end up with 7 factorial, which if we multiplied all of this out, we're going to get 5,040. Okay, now what happens if we start with an A and end with an S? So A, 1, 2, 3, 4, 5, 6, and then end with an S. Well, essentially we're taking out the A and the S from the equation, and we just have a 1, 2, 3, 4, 5, 6. So we're going to start with 6 factorial on top, and then the bottom is just the values of the remaining. And so they're all 2's, so 2, 2, 2. And so we get 6, 5, 4, 3, 2, 1. We get 2, 1, 2, 1, 2, 1. Once again, that's an 8 on the bottom. So if we cancel 8, we can do 2 times 4. We cancel that. So 6 times 5 times 3, because the 1 won't matter. And if we do that, we're going to get 90. Okay. Which start with C and end with L. So we're going to say C and L. Now, once again, the top is going to be a 6 factorial, because we're essentially taking out one of the C's. So let's see. We have the A back in, we have the S back in, but we're taking out one of the C's. So now we just have one C. And we're taking out one of the L's, so we just have one C, or one L. What am I talking about? One L. But we still have 6 left over. And so we're going to get 6 factorial, but with the stuff that's left over, there's only 1, so 1 factorial, 1, so 1 factorial, 1, so 1 factorial, 2, and 1. Okay, if we do that, the bottom is just going to be a 2, and the top is 6, 5, 4, 3, 2, 1. So these 2's will cancel, the 1 doesn't matter. So if we do 6 times 5 times 4 times 3, we get 360, and so there's 360 for that one. If you need additional help, please come to Math.